So good afternoon, everyone. We can start the deep dive session about smart water. My name is Fernando López. I am a cloud and platform senior expert inside the FIWARE Foundation. I am working in FIWARE technology since the beginning. I have several roles inside the foundation, like a principal cloud architect of the FIWARE labs, a co-chair of the quality assurance working group inside the technical steering committee, and also co-selected in the FIWARE lab chair. I have more than 10 papers, a book, review on the Springer wireless personal communication magazine. We have a very interesting session today with a huge number of good presentations. And we can start with my presentation, the introduction of the FIWARE Foundation. Afterwards, we go to the opportunities in the water sector, the vision of from the European Commission, provided by Dr. Panagiotis BALABANIS. Then we have a Digital Water 2020 Synergy Group vision, ambition and main objectives presented by Dr. Nicolás Caradot from the Kompetenz-wasser Berlin. Then we have a presentation about the FIWARE vision and the value proposition for water, presented by Dr. Franck Gall, CEO and CTO from EGM. Sorry, I put the previous name. Then we move to some demo cases, use cases, in which the use of the FIWARE technology is relevant. We started with developing application for raw water supply systems management, presented by the Dr. Christos Makropoulos. Then we have an expert session about the connection between the EPANET simulation tools and the FIWARE technology, presented by Dr. Sweetapple. Then we have the last expert session regarding the integration of SWAT and MODFLOW into the FIWARE technology for watershed monitoring, presented by Benbrahim. And finally, we have the wrap-up, a summary of the different presentations that I took notes. I presented the Mission Support Committee, the FIWARE Smart Water Mission Support Committee, in which our CEO Ulrich will provide some words on that. The introduction of the FIWARE for Water Challenge, just to finalize the session. So some reminders. I will control the time because we are very strict on that. The session will be recorded, will be available or either in YouTube channel or any other mechanisms that the FIWARE marketing team will provide. Just last but not least, questions. If you have some kind of questions, please go to the right side of the windows and drop there whatever questions you think that is relevant from the session. And not taking more time on that, I will present the first speaker. It's Dr. Panagiotis BALABANIS. He's a doctor for the University of Joseph Fourier in France. He's working he's head of water in the circular economy and Biobased system unit, directorate general in the research and innovation from the European Commission. He has been working at the European Commission since 1990 in the Research and Innovation Directorate General. He's currently head of the water sector in the circular economy and Biobased system unit. And of course, in that context, he is very related to the water, resource efficiency, circular economy, with a view support to the transition to the healthy planet. And of course, taking into account this role, he's also involved in the definition of and implementation of the successive research program in the field of water, environment, and sustainable development. So, Panagiotis, the floor is yours. Let me stop my sharing.
Yes, good afternoon, everybody. Thank you very much, Fernando, for this introduction. Let me, let's say, first of all, provide, the political context and trying also to put also water in this political context, and then in the second part of my presentation, try to present a bit more details on the research and innovation dimension of that. As you know, the current Commission has already put a lot of emphasis on what we call now the joint, the green and the digital transition. So these are one of has been already identified in the political priorities of the Commissions. And here, let me just, remind you the European Green Deal. I suppose that you are, many of you are already familiar. What is important there to stress is that, for the first time also, the Commission also put a strategy, this European Green, which is a kind of respond, to the climate and environmental also related challenges. But also, on the other hand, this is also an agenda. This is a policy also to support. This is a kind of what we call a new also growth strategy, which aims also to transform also the EU into a fair and prosperous society, while having also a competitive economy, but at the same time, also there are no net emissions, of greenhouse gases, and so the economic growth is decoupled of resource use, because we know that this is also the problem that we currently also face. What is important also to stress is that also this policy is about the European Green Deal is about also enhancing also the EU's natural capital, and of course water is also very important there. And last but not least is also a kind also this strategy is part also of the Commission strategy and commitments also to implement also the Sustainable Development Goals. So here I would like just to illustrate, the elements. You can see the different elements of the Green Deal. So as I said, there are different policy elements and initiatives which have been adopted since the European Green Deal. And here I would like just to illustrate, a few of them that perhaps you are familiar. So you can see that within the new Circular Economy Action Plan, within the biodiversity farm to strategy, there are many water-related issues. But I would like just to highlight a bit, the recent strategy on the climate change adaptation strategy, which put, as you can see here, water is resilience of water to climate resilience, water management is a key element on that. And so this climate strategy would like also to ensure a climate resilient, sustainable use as management of water, which is also across also to the different sectors. I think this is very important. And I think this is very important also contributions to the digital technologies can help also to make also the links to address, for instance, the nexus between, between water, between energy, and also agriculture and food. Another also important elements of this of a recent strategy is this zero pollution for air, water, and soil action plan. I think you understand already for the title that this is a very relevant about water and pollution, also reducing also water pollution. But what is also important is that there have been several flagship initiatives which have been also identified, and one of them is a kind of the establishment, the launch of living labs for green digital solutions and smart zero pollution. And I think this is also, again, as I said, also very relevant to the water and digital agenda. What I would like also to mention here is, of course, that also the Green Deal also acknowledges also the importance of digital technologies, and for as a critical, let's say, enabler also to attain also the sustainability also goals. And so this is also linked with the Europe Fit for the Digital Era also agenda. So this is also, as you can see, the digital technologies are recognized as an important element. Let me now mention about Horizon Europe, and first of all, I would like also to present, the structure of Horizon Europe. I suppose that you are, a bit familiar with this structure, but what is important also to highlight that this is Horizon Europe is built on Horizon 2020, the previous work program, and what you will see here, you see the three pillars, and you will recognize also the importance. You recognize also the links also with Horizon 2020. What is important also to strengthen also here is that, of course, the Horizon Europe is not only considered as a kind of funding, support for research project, but I think this, for the first time, I think also Horizon Europe is considered as a way also to support also the political priorities. So this is very important to stress that Horizon Europe is linked to the policy priorities that I mentioned just before, a European Green Deal, for instance, digitalization. So these are also elements embedded. So in looking also to implement the Horizon, we will have also to highlight also how we can also contribute, how we can also achieve these challenges. The cluster, the pillar 2 is, as you have seen before, is one of the main, let's say, part of Horizon Europe, where the majority, more of half of the budget. By the way, Horizon Europe will have a budget overall which is 95.5 also billion also euro, and so half of them, about 52 billion, will be also for the clusters. Here you can see that the different clusters. I don't want to go in the details, but of course, I'd like to mention that there are water is going to be also addressed in several of them, even if it is, for instance, not explicitly also mentioned, in particular in the cluster on digital industry and space. You can see areas about, key digital technologies, artificial intelligence, for instance, their water also could be also addressed. But of course, the main cluster where water activities will be is the last cluster. This is the cluster about food, bioeconomy, natural resources, agriculture, and environment. And I would like a bit to spend some time for that. What is important is, as I mentioned here, what I would like to highlight is that as we have tried in what we call the strategic planning. This is a planning where we have also identified strategic orientations. We have also committed also to address also the political priorities. This has been also discussed with the different policy DGs, but it has been also discussed with stakeholders in several, for instance, research and innovation days. And here you can see 6 of the what we call expected impacts, the long-term targeted impacts of cluster 6, which have been also identified in such a way also to support the European Green Deal. And so I don't have to stress, if you look also with the first slides, you will realize that all of them, the 6 also targeted impacts, are linked to the relevant initiatives in the Green Deal, farm to fork, circular economy, climate, biodiversity. Let me go a bit more in detail as I said, water has been addressed extensively in cluster 6, and here you see across also the different also expected impacts across the different destination areas we have defined. You can see that water has been very important. I would like to mention in particular in the destination land, ocean, water for climate action activities dealing with observation and water availability is about climate sensitive water allocation systems. There, for instance, of course, digital technologies are very important. And then, of course, in other elements of the program, the contributions to zero pollution, but also we have also a dedicated focus on environmental observation, digital solutions, innovative governance, and here you can already also see that water and digital contributions will be also very important. Let me also mention another future of Horizon Europe and particularly also in Cluster 6. As you know, the Horizon Europe also provides support to the partnerships, and these European partnerships are a mechanism, is a way to bring together, to aggregate research at the European, national, and regional scale, trying also to coordinate national activities with the European activities. And within this partnership, we have also proposing a European partnership in Water for All, which is water security for planet. And this is a partnership which is going also to address also the different, also the wider also climate water emergency crisis related also to both water pollution, emerging contaminants, biodiversity decline, extreme hydrological events. And this is going to be also implemented through dedicated calls. So the partnership will have also dedicated calls in addition to the calls which will be issued also in the context of the work programs. Here I would like just to give you a highlight. You can see, for instance, the main thematic also priorities which will be addressed in the Water for All. Here you see the current draft, what we call strategic research and innovation agenda. But what I would like also to mention is that, as you can see here, that the digital revolution is also considered as an enabler also to these different also thematic priorities. So water and digital will be also key elements in the Water for All. And then let me also just highlight also another future of the Horizon Europe, which will also have dedicated calls. This is about the missions. And as you can see, this is also missions is a way also to try to create also impacts, try to also increase awareness of the citizens about the impacts that research and innovation can provide for them. And this is the Commission also proposed 5 missions, and as you can see, 3 of them at least and related with ocean inland water, about climate change, about soil and health and food are also, as I said, this is water related, so it will be also important to look on that. And then just to, as a way of conclusion of my presentation, also to highlight that, research and innovation will play also a key role in achieving, I think, this both green and digital ambition. As I have indicated before, the European Green Deal initiatives, particularly many of them, give many opportunities for water-related action. And last but not least, also Horizon Europe will also promote a lot of activities in water, and within also these activities will also provide opportunities to demonstrate also the potential of digital solutions, going beyond the individual also solutions, but trying to have a more systemic type of approach within also the water, but also within also the smart water value chain. And with that, I would like to thank you for your attention and apologies for the small problems in showing the slides. Thank you.
Welcome. This was a fantastic presentation. I think that with a huge potential from the short time. Thank you, Panagiotis. Then we can move to the next speaker, Dr. Nicolás Caradot. He is a doctorate for on the topic of simulating sewer asset management strategies. He is working since 2010 in Kompetenz-wasser Berlin, close to my house, to be honest. He has contributed to different or numerous research and development projects on urban drainage monitoring, modeling, and decision making. His research area is about the use of data, statistics, and machine learning to better understand the behavior of the urban networks and increase the rationality of decision-making processes. Currently is taking the role of the coordinator of one of the synergy group project, the Water City, and he, last but not least, he has a chair of the UDAN working group, Urban Drainage Asset Management, from the Joint Committee of Urban Drainage, and is member of the Management Committee of the Specialist Group of Strategic Asset Management. So, Nicolás, the floor is yours.
Thanks a lot, Fernando. I hope you can hear me and see my screen, because now I don't see you anymore. I see only my screen, but
perfect. It's perfect.
I guess it's working. Excellent. Okay, so thanks a lot for the invitation. It's a real pleasure to be here. Today I'm going to present you briefly the vision and the activities of the Synergy Group Digital Water 2020. So thanks, Fernando, for the introduction. I work in Kompetenz Center for Water, Kompetenz-Wasser in Berlin, Germany, and I'm the coordinator of Digital Water City, which is one of the digital water projects funded by the European Commission in Horizon 2020. And this Digital Water 2020, what is it? It's a synergy group, meaning it's an operational group where we aim at working together with the 5 digital water projects. So these are all projects that started in 2019 for 3 or 4 years, and which aim at developing and bringing to the market digital solutions for the water sectors. So of course, they have different case studies. Altogether, we are working with more than 15 utilities and municipalities in Europe and developing a huge range of different types of digital solutions and digital technologies. And we want to show what are the benefits and also the risk associated to these solutions. So what's interesting is this Digital Water 2020 is that it's an operational group, meaning we are working together on a daily basis. And at the end, what we try to do is to avoid reinventing the wheel and find synergies where we can. So we have 4 main task forces that we are working together and which are of interest. The first one, it's a task force related to FIWARE and ontology or data models. And the goal of this work, of this task force, actually Franck Gall, which make a presentation, I don't know if he's the next presenter, but later today. The goal of this task force is to develop interoperable data models along the entire value chain, so along the water cycles, which are compatible with NGSILD and also FIWARE. So we are putting our effort together from these 5 projects and these 15 utilities which are testing the solutions to come up with some coherent data models. The second topic where we are working in common is the deployment of sensors and the demonstration of sensors added value. So there we are working on the integration of sensors into FIWARE architecture, sharing experience between cities, utilities, and different companies that are developing sensors. And we get return on experience also on innovative sensors and the use of these sensors. An interesting part of the work is the work on business model, because there also to avoid reinventing the wheel and that we all do the same activities, we try to work together to support the commercial exploitation of these different solutions and to increase at the end the uptake that our solutions can have on the market. And finally, we have some communication activities. There it's a bit more classic. It's easier than if we can work together since we have very close objectives. I will go quickly on the main ambition and activities that we have in these groups. So first, I was mentioning the data models. So there we have different projects plus additional projects that are joining the team. We are covering almost the entire water cycle and urban water cycle. And the idea is that from each of these projects to define what are the needs in terms of data model, in terms of coherency and exhaustivity. So the different types of model that exist. And then we define some groups for each of these model to try to come up together with something coherent that can be applied in different locations and that can be integrated into the FIWARE architecture. So we have this process in place. We have first models which are available on GitHub and on smart data models. And this is a work that is going on. It is quite promising for the moment. On sensors, I wanted to give you a quick overview to have something concrete on what are these projects doing. So we are bringing to the market new sensors. These are some examples. For example, in the project Aqua 3S, they are developing a so-called refractive index sensors, which is based on refractive index analysis into the water, and which should act as an alarm if the water composition is changing. So the idea is to have a simple sensor that can tell us when there is a different pattern in the water, and we can define an alarm, for example, for the protection of water reservoir on drinking water production. In Core Water, another project, there they are developing a so-called turbinator, which is a nice name for a new sensor that measures turbidity online. And what's quite interesting on this sensor is that it's based on laser reflection. So as we can see on the picture in the middle, it's not a sensor that is installed into the water. We measure from the well, for example, from the manhole, with a laser, the reflection of water of the laser into the water, and from that we are able to calculate the turbidity or the concentration of suspended solids. So this is quite interesting also to reduce not only the cost but also the maintenance needs in such harsh environment as sewer or stormwater networks. And in Digital Water City, we have different solutions. We have one which is quite interesting. It's a new sensors developed by the company Fluidium in France for in situ microbiological quantification. So basically, we can measure online E. coli and enterococci using fluorescence-based measurements. We can install the sensors in the rivers and measure continuously what is the water quality. And we are deploying the sensors in the project in Paris and Berlin to assess the water quality in bathing sites on the river and monitor the risk of contamination. Last sensors, which is of interest also that we are developing and testing in Digital Water City, it's a low-cost sensors based on temperature measurements. This is an example of the city of Berlin. Here you can see the house of Fernando, actually, which should be more or less in this area. And all the points, they are monitoring location where we are deploying these very cheap temperature sensors. And on the next slide, you can see the principle of these measurements. It's very simple. It's with one temperature sensor, we measure the water temperature at the combined sewer overflow location, so where we have discharge from the sewer network into the river. And at the same location, we have a sensor which is on the crest of the overflow. It means it measures air temperature during dry weather and water temperature during wet weather. So basically, on this graph, you can see over several days, when the temperature is the same, it means we have an overflow because we are measuring water on the crest of the overflow. And when you have a deviation, it means we are not measuring the same thing, so there is not overflow. So the idea is to use that to install a lot of sensors in all the combined overflow and have a better knowledge of the behavior of the network. Also there are some interesting works related more on the integration of sensors into FIWARE. There is an interesting collaboration going on, for example, between the utilities in Milan with Cap Holding and Amsterdam with WaterNet, where they are both deploying different type of online sensors at the wastewater treatment plant for different purposes. So in Amsterdam, it's more about treatment optimization, whereas in CAP, it's more about creating some early warning for reuse and predicting some parameters. But at the end, they have the same objective to have all this system functioning and all the sensors integrated into FIWARE. So we have some direct collaboration to make that work. Also, something I wanted to mention is the work linked on business development. This is something going on, but that will be quite interesting because we are working on a kind of catalog of digital solutions where we want to put together all these solutions that will come from the project. So only in Digital Water City, we have 15 solutions, but that's more or less the same that is happening in the different projects. And at the end, we want to be able to show what could be the contribution of these different solutions to European policies, or at least facilitate the matchmaking between the solutions and potential end user. So if you look for a specific solution for wastewater network, for example, you will be able to identify quickly what are the innovation coming from this European project that you could apply in your city during and after the end of the project. So on communication, of course, there are a lot of activities going on. I will not go into detail, just mention that we are organizing at the SIM Hydro conference that is actually in few days happening in France and digitally. A session on digital twin for the water sectors, so sharing experience from the different projects on this specific topic of digital twin. And lastly, the last slide for conclusion is to say that the next building block we are working on is to work on policies and to be able to show better what is the contribution of these 5 different projects to European policy. So we had a first exchange with the European Commission in January on this topic, and it's a work that we are following up at the moment. The idea is to be able to show very clearly what are the different contributions that each project can have to these different policies, and be able to show a bit better what are the needs or some proposition potentially to adapt the policy, or at least to show what are the tools which are now available to address fully this policy. And I think that was the last slide. So thanks a lot for your attention. And if you have any questions, don't hesitate to contact me also directly per mail. Thanks a lot.
Thank you very much, Nicolás, for your presentation. It was very interesting to see the collaboration activity between all the projects inside the Horizon 2020 of water activities. So then move to the next presentation, or the next speaker is Franck Gall. He's Dr. Franck Gall, sorry. He, by the University of Rennes, he's CTO from EGM, an innovative SME company focused on integration and validation of emerging technologies. He's co-chair in the ETSI ISG SIM working group, in which is defined or is working in the definition of the ETSI NGS ILD API. Also, he has a chair on the interface working group inside the FIWARE Technical Steering Committee, and co-chair in the Smart Water Working Group of the ICT for Water, that European Research Cluster, and is joining ETSI FIWARE Foundation Working Group in the definition of digital twins. So, Franck, the floor is yours.
Okay, thank you, Fernando. Thank you all for being here listening to us. I hope you can hear me clear and that you can see my slides full screen.
Perfect.
Good. I'm going to present the FIWARE vision and value for proposition for the water sector. Okay, you know, we got it in introductions. The value of water, it's one of the critical resources we have to take care for the coming years. And if we want to speak about digitalization in the water sector, then we have to tackle both the value of data and the value of water. And to do that, we have to consider the whole water life cycle. So here you can see this nice diagram which has been made in the context of the ICT for Water research cluster. I will come back to it a bit further later on. And here really we start from the whole part. So what are the sources, ecosystem on the rain, groundwater surface, abstractions, or we get the water, or we clean it, or we distribute it, our thinkable water, looking at what are the consumption scenarios, and then how we do collect the wastewater and how we can reuse it, treat it, gray water, or put it back in the cycle. And for that, there are a number of technologies which are in use. So Nicolás started mentioning some of them which are being developed in the project, and this is what we have to look at. I was mentioning the ICT4Water cluster. So a few words about it. It's something which started in 2012. It's an initiative to group the different research projects, and the DW 2020 that Nicolás was presenting is emerging from that. It's a group of projects which started at the same time from within that cluster. And this cluster encourage synergies across the project and also with external stakeholders. So there are a number of interactions which are taking place on a daily basis through the projects with the ICT4Water cluster. It produced an action plan, which is defining a number of items to be looked at for water digitalization. And this is being tackled through a number of different working groups in the cluster. And myself, I'm involved in a smart water one, but obviously many of them are of interest when we are looking at FIWARE technologies, and starting with the first one on standardization and interoperability, obviously. Nicolás shown that slide already. I will go to a bit more detail about it. This is an initiative that was done to progress the development of data models. This is really central. When we want to exchange information, connect systems, then we need to align data models. And in FIWARE, you know, we are using the NGS-ILD specification, which is a cross-domain specification to exchange information across different domains. So it's agnostic at the start from the domain, but we can connect and develop new domain-specific models on top of it. So what this group is doing, it's from the use cases in the project, we have a number of needs which are expressed, looking at the overall value chain of or life cycle of the water, and then looking at what are the existing models. Someone is talking. Looking at the existing models related to water or others, and for the Internet of Things, for geographical information systems, but also for social networks, multimedia, and so on. So all of these are of interest, are considered and developed using the NGS-ILD specification from ETSI. And to do that, through the smart data models, which is being pushed forward by FIWARE, contribution process or workflow has been defined and is being followed by the project. So every week there is one conference call, so all people from the projects involved in data modeling are meeting and progressing the models all together. And this workflow has been improved through that collaboration. And all of this is publicly available for use because it's really in the overall spirit. We are looking for interoperability, so we have to share all that work. Quickly on the contributing projects that I know, the first one, Aqua3S, which is looking, for example, more specifically on cybersecurity and safety aspects in water network. And so it's not only looking at IoT things and sensors, but also about social networks to detect some possible alerts, which may not be visible by sensors, but also connecting drones or satellites information. Another one interesting, it's Lotus, which is in cooperation between Europe and India, and it's looking at a number of different use cases in India, a bit different, but still it's based on the FIWARE technology. And one of the aspects there, it's using a new innovative sensors, which is going to be deployed in a number of different use cases. So here you can see the middle. I like this one where you have the tanker-based water distribution system. So onboarded, we have the chlorination aspects of activities for the water, which is pushed back to the cloud in real time. And last but not least in my list, the FIWARE for Water, where FIWARE Foundation is part of it, and where we will have a presentation later on, but simply we're connecting smart meters and connected to a Stelio FIWARE context broker simulator, where we are developing a digital twin based on this simulator to provide new information for both the utility manager and the customer. But we'll have more information from Chris later on that project. What is being progressed by all this project is the common architecture vision, which is then part of also the FIWARE offer. So if you know a bit on the FIWARE ecosystem, you have these catalogs of enablers. So each block can be or is a different enablers you can pick in the FIWARE catalog. And here we identified some of them more specifically for water. So you have different adapters which have been improved to deal with the use cases of the project. We have the context broker, usually the usual context broker, which can then run or connect to the different processing engine. And here, depending on the project, we have different approaches to connect to geographical information systems, or we are also developing some machine learning as a service approaches where different people can come and provide their own models and push them into the system. And maybe I forgot to put a slide on it, but maybe I will put the links in the chat through this FIWARE for Water project. There is a challenge which is running now for SMEs. So SMEs willing to take part of it are welcome. So they will be able to make use or to connect to that architecture which is being put in place by the project. So overall, if I look at the FIWARE value proposition for water, first, there are data models, so which are based on the NGSILD specification from ETSI. They are developed by the project based on the different use cases from the project. It's under continuous development. It's not something which is closed and finished. Unfortunately, there is still a lot of work to be done. So any project willing to join, to contribute to that, to reuse, is more than welcome to join the team and contribute to this model. Is simply driven by use case needs. So this is what sets the priorities in developing the models. And we really intend to cover the whole water life cycle, so to be able to provide a global DSS decision support system at the end. And associated to that, we have this reference architecture I was talking about, using interoperable components from the FIWARE catalog. These are being demonstrated on the field. We have several use cases which are using it now. In all use cases, it's not only the sensory part, but it's up to the decision support systems through the use of digital twins or machine learning as a service approaches for the project. And also we have a community of adopters. So all of you today being present who are interested by this, I think you are part of that community. So do not hesitate to come to reuse and bring also your proposition for FIWARE in relation with the water domain. So I think it's short, but it's what I wanted to say on that topic.
Okay, thank you, Franck, for the nice presentation about the added value of FIWARE technology in the water sector. Then move to the next use case. This is presented by the speaker, Dr. Christos Makropoulos from the National Technical University of Athens. He is professor at the School of Civil Engineering in National Technical University of Athens, principal scientist in KWR, the Water Research Institute in Netherlands. He is also a fellow of the UK Higher Educational Academy and the Royal Geographical Society, co-editor-in-chief of Urban Water Journal, a member of the editorial board of the Journal of Hydroinformatics and editorial board of Water. He is expert in hydroinformatics expert in hydroinformatic tools and methods for urban water management, with an emphasis on distributed urban water infrastructure, critical infrastructure protection, and whole cyber physical system modeling of digital twins. Author of more than 70 journals, hundreds of conference papers, and several book chapters. So, Christos, thank you to join this session, and the floor is yours.
Thank you very much. Can you see my screen?
Perfect.
Excellent. So, we have already heard quite a lot about FIWARE, of course, and some of the opportunities that it affords for interoperable internet services for the water sector, and also beyond, I would say. Now I will spend the next few minutes looking at one of the very first implementations of FIWARE for the sector, for the water sector, focusing on optimal operation and management of raw water systems, open channel aqueducts. And the work I will be reporting on has been undertaken within the framework of the FIWARE for Water project. Franck mentioned this project, and this is a project funded by the Commission within its Horizon 2020 program, whose specific focus was to explore and demonstrate how FIWARE interoperability can be used by the water sector. The project started in 2019, finishes next year, and essentially looks at three things. It develops smart applications using FIWARE for real-time management of water systems. It then develops water-compliant interfaces to integrate these smart applications with existing legacy systems within the partner utilities. And, of course, and importantly, demonstrates FIWARE benefits and capabilities in terms of interoperability, standardized interfaces, and so on, through 4 demonstration cases. And each case looks at a different component, if you like, of the overall smart urban water cycle, as Franck put it earlier on. So from raw water, which will be the subject matter of my presentation, to distribution networks, which I think Chris will mention later on in the context of EPANET, to customers and smart meters, and all the way to treatment plants and digital twins thereof, the wastewater treatment plants, as it were. The first of these demo cases is the raw water supply of the system of Athens in Greece. And actually, the system, the Athens water supply system, is a bit of a challenge, I would say, because it is a really very long system of a total length of more than 500 kilometers of aqueducts, conveying raw water from a number of reservoirs, 4 reservoirs, starting all the way at the western side of the Greek mainland and moving water to the treatment plants in front of Athens, which is essentially the eastern part of the mainland, so crossing half of the country. And in doing so, there are at least 23 structures regulating flow in the channel, hydropower stations producing energy by gravity, stealing basins for energy dissipation, all sorts of hydraulic features and structures that need operation. This operation by the Water Company of Athens, called ADAP, relies on a network of sensors that monitor both, of course, quality and flow characteristics of the raw water. So what was the challenge? The challenge was, in effect, to upgrade the overall supervisory system of the hydro conveyance, the aqueduct system, adding a layer of monitoring and advice provision on top of the existing SCADA, but integrating several different sensors, interface with and provide added value to legacy systems, and develop specific applications, specific hydroinformatic applications to support the management of this hydro system through FIWARE compliant analytics. And 2 types of analytics were of particular interest to ADAP, the Water Company of Athens: raw water flow management applications that are able to monitor and control in real time the flow regime across the conveyance system, and raw water quality management applications, which are able to provide early warning for unusual events, so things like high turbidity, and send alerts and alarms to both system operators, but also treatment plant operators downstream. And to support this integration of FIWARE with ADAP's legacy system and these 2 new families of applications that we developed, a FIWARE reference architecture was designed, as Franck mentioned. So this included the Orion Context Broker and its MongoDB counterpart, but also a series of other FIWARE-ready generic enablers, such as the IoT agent and the Cosmos Big Data generic enabler. And we did this also in the spirit of allowing some additional experimentation for both ADAP and ourselves in terms of different ways of using FIWARE, and these experiments, let's say, are very much ongoing. We're looking forward to insights for this. Now, interestingly, ADAP use the project, this particular project, as also a motivator to proceed with an internal data project of their own, that of data flow integration from all sensors into a single data warehouse, which then became the data source of the FIWARE interface we were using. And now to establish connections between this warehouse and the applications, we configured an FTP server, database schema and scheduler, and currently all of this data is transmitted in real time. Now we also developed a data mapper to establish a common format and push them to the CSV IoT agent. And additionally, to store data persistently, we use the Draco module. So Draco is notified when new data become available in Orion and inserts them into the SQL queries, let's say using SQL queries to the Postgres and PostGIS database server that then serves the smart application with the data. And we have installed and tested all of these components in our servers, and these are all fully functional at this moment. Now, what was the smart application in our case? We developed a web-based platform based on a technology we call Nessie. Nessie as in the well-known water monster. And this platform analyzes and visualizes real-time data from sensors in the conveyance system. And the system also was customized to integrate into one common interface data from flow meters, water level meters, sluice gate opening, data from water quality sensors, because of course ADAP wanted to have access to all of this in the same dashboard, as well as daily inflows and outflows from the treatment plants to have a common operational picture. Now this system is currently live, receiving real-time data from both the water quantity and quality sensors. Two dashboards on quality and quality are already deployed, so the users can navigate by water property, by metering station, using interactive maps, drop-down lists, and all graphs can be very easily zoomed in, narrow time windows to focus on particular events, and of course other functionalities like superimposing different time series for comparison of key variables are also available. Now, further to Nessie, we also developed a series of more advanced analytics to support real-time decision-making. So, for example, some of these analytics cover automatic detection of unusual flows and quality events. Some work on the analysis and forecast of daily water demand volumes, and also identify, let's say, or come up with early forecasts of exceptional events, which would trigger exceptional use of the sluice gates to bring water faster than anticipated. And the last application is one where we estimate the optimal sluice gate setting configuration to establish specific flow conditions in the channel. It's actually quite tricky. And just to spend a few more minutes on this, what we did is we are developing and evaluating a physically based model that is able to simulate the flow over spillways and through sluice gates that operate the whole system using a number of regulation structures. There are several of these regulation structures to allow water to move from one side of the country essentially to the other. And in this live environment, the model receives the latest upstream and downstream water depths at each sluice gate, and then given a target flow that the operators of the system provide to meet the needs of the city, then the system provides advice on the new gate opening. And this analytic is about to be implemented in the lower part of the system, so the one nearer to Athens, where the flow is regulated via 6 sluice gate regulators, such as the one that you see in this slide, the upper right-hand corner. Now, to support this integration and information exchange of these analytics, and especially the hydraulic model, with FIWARE components, we developed a series of generic and easily extendable data models, which is a point also Franck made, for the domain of raw water supply systems, open channel flow, and we identified and described, according to NGSA standards, properties and relationships of the key physical elements of a typical system, so things like channels and junctions, regulation structures and regulation gates and spillways, So as you can see in this graph, these entities can be combined via the relationships to define a raw water system. And you can also define an entity we call cross-section, which essentially is the place in the system where raw water variables are monitored by a device, and this could be a sensor or computed via a simulation model. And currently we are developing 2 additional data models to describe properties and relationships associated with the setup of the hydraulic simulation scenario and the simulation results. And I'm putting here a link to the relevant repository. You can have a look and explore all available data models if you like. So to conclude, I would say that the key lessons from this exercise is that certainly interoperability of the FIWARE kind, the kind that interoperability FIWARE affords, I think opens up real market opportunities for advanced hydroinformatics solutions and allows niche tools such as those developed by SMEs, but also research institutes, to be integrated into operations of real world water companies without too much time wasted in ad hoc linking solutions. And once these standards are defined, then collaborative work is key to develop these data models that become, if you like, the maps of interoperability. And this is currently what is happening within the project, but also the alliance, the synergy group that Nicolás mentioned earlier on. And certainly we could use more help and involvement from the water world and all of you on this. And we should also acknowledge, I think, that the EU has taken notice of the fundamental opportunities such a market also for SMEs entails, and is pushing for interoperability across a range of initiatives that are relevant for this discussion, including all the topics that Panagiotis mentioned at the beginning of this session. So smart utilities, smart cities, digital twins, smart data hubs, carbon neutrality, the Green Deal, and circular economy. These are all underpinned by interoperability of the FIWARE kind, I think. And as such, I think also it's fair to say that the Commission funds projects where the space for research and practice to come together is created. And in this co-creation process, I'll say it one more time, interoperability of solutions like FIWARE is key. So I will leave it at that, I think. Thank you very much for listening. Watch this space, as it were. Thank you.
Thank you very much, Christos. It was an amazing presentation to see how can we apply the FIWARE technology into a serious game. This is a fantastic adoption of the FIWARE in the resolution of real water sector problems. Oh, it's fantastic. So thank you again. So then move to the next presentation. This is an expert presentation regarding the integration of EPANET simulation tools with the FIWARE architecture. It will be presented by Dr. Sweetapple from University of Exeter. This is a doctorate on strategies for the reduction of greenhouse gas emission from wastewater treatment. He was awarded with the Scopus John Research UK Award regarding this activity. Currently, he's working on several water-related projects. So, Chris, thank you again to join the session, and the floor is yours.
So I'm going to outline some developments that have been made on linking EPANET to FIWARE under the FIWARE for Water project. So just to start off, for anyone who isn't familiar with EPANET already, it's a program that's available for modeling water distribution systems, and it's widely used both in academia and industry, and also forms the sort of foundations of some other modeling software as well. So it allows us to carry out extended period simulation of hydraulics and water quality behavior, and it gives us outputs for the whole network, including sort of flow rates, pressure at different nodes, how much water is supplied, and various water quality parameters as well. EPANET includes a GUI and also an open source toolkit, which enables us to run simulations programmatically and manipulate models, and that's what we're using for linking with FIWARE. So in terms of why we want to link it with FIWARE, EPANET models are generally static, so they don't necessarily reflect the network in its current state. So linking with FIWARE will be really useful to help us with real-time modeling and operational management. And also just generally help us to integrate it with other sources of data and help ensure our models remain up to date. So sort of like the first step of this is to produce a data model, which allows us to store all the associated data in an appropriate format for FIWARE. So for this, we've produced a new water network management data model, which allows us to store all of the information that's needed to generate an EPANET model of a water distribution system. So I've got a screenshot here from the repository for this and a link if anyone's interested. So this shows some of the different entities included in the data model. So these map pretty well to how a network is defined in EPANET. So we've got separate entities for junctions, tanks, reservoirs, pipes, valves, and pumps, which represent the key components in an EPANET model. And we've also got entities for curves and patterns, and also simulation results and simulation scenarios, which I'll touch on later. So just to show how this can actually be used to represent a network. So in EPANET, a network is represented as a series of nodes and links. So I've got a very simple example here. And then to sort of map this into the water network management data model, you can see here all the green boxes are different entities, and we've got one of those for each node and each link in the model. And then for all of the links, which are the ones on the green boxes on the left, we've got a starts at and an ends at relationship, which connects them to the corresponding nodes. So that shows how everything in the network is connected together. And then we can add more information to each of these entities. So for example, for a pipe, you've got various properties, including its length and diameter and others. And then you can assign values to each of these properties. And so to fully define this network, you end up with a slightly more complex diagram that looks a bit like this. So this is a graphical representation of a network, or how a network is represented within the data model. In reality, everything is actually represented in JSON LD format, which looks something like this. So in terms of a process of actually connecting EPANET with FIWARE, so EPANET models are all defined with a standard input file. I've got an example shown here. So our first step is to convert this into the JSON LD format, sort of in accordance with the data model. So to do this, we can use the EPANET toolkit. So we can load an EPANET model from the input file, automatically extract all the component data, and we can generate the requisite JSON LD from this. And then we want to store this model using FIWARE, so we can post these to a FIWARE context broker. So this should be a one-off process for integrating EPANET with FIWARE. It's just done once at the start, and then we don't need to go back to our EPANET input file at all. And so then next, our model is going to be sat in a context broker, and we might want to update this. So we could have information coming in from various other sources. We might have sensor data that relates to different parts of the network, or modifications might be made to the network. So those should all be fed in via the context broker, and those can be used to update the information on the network that's currently held. So We then want to retrieve the relevant data when we want to run a simulation. So this is all the most up-to-date data, so it might not reflect what was the original input file, but reflects the current state of the network. So we can retrieve all this information from a context broker, and we can use the EPANET toolkit again to generate a new EPANET project. And then we can use this for various different purposes. So we could use it for visualization, and we could run simulations with it. We might also want to sort of test out different scenarios, or maybe try applying interventions. So we can modify the EPANET project and run simulations to see what impact they have. I also mentioned various simulation-related entities. So we also have a simulation scenario entity, which allows us to fully define an EPANET simulation. So this is important if we want to be able to repeat any of our simulations, and also if we're saving results, we want to be able to show how they were generated. So this is particularly important if we're simulating lots of different scenarios. We need to be able to distinguish between them. So our simulation scenario entity allows us to capture, firstly, all the components or all the network components that we used in the simulation. Also, any simulation options that we used. So, for example, time steps. It also captures any modifications we make to the network. So, for example, if we're trying to simulate different scenarios, we can store any of the changes that were made under those scenarios, and also any operational rules or controls. Next, we have a simulation result entity as well, which allows us to store the results from the hydraulic and quality simulations. And you can see here how this is linked to the simulation scenario entity. So our simulation scenario has a simulation results relationship, which connects it to the simulation result. We can also go in the other direction as well. So if we've got a simulation result, we can see what the simulation scenario that was used to generate that was. For both of these entities, we can also see what input network was used. And then for the simulation result, we've got various output parameters that are properties of this entity. So these might relate to different network components and different properties of these components. So, for example, flow rates for a pump, for instance. So very briefly, that's sort of described how we can link EPANET with FIWARE. We've got some ongoing work applying this to a number of case studies. So this includes one in the FIWARE for Water project, where we've got a small town in the southwest of England. We've got a water distribution network model, and we've also got smart meter data, and we're integrating those. So that's actually going to be presented at the SimHydro conference next week, I think it is. Yeah, so that allows us, or sort of is demonstrating how we can use FIWARE to integrate EPANET with sources of real-time data. And then there's also ongoing work on the implementation of the simulation scenario and simulation result entities. So thank you very much.
Very appreciate your presentation, Chris. It's amazing to see one of the most water simulation tools integrated into the FIWARE. So thank you very much for your session. Then move to the last expert session in order to see the integration of other tools, other important simulation tools. In that case, we have the speaker is Benbrahim. It's a master degree in physics and electronics at the University of Pierre and Marie Curie, Paris. He's senior engineer in embedded system and telecommunication system at Tritux. Vice chairman of the mission support committee FIWARE iHubs, and also coordinator of the FIWARE iHub in Tunisia. So Ali, the floor is yours.
Thank you, Fernando. I hope the voice is okay, it's clear.
It's clear.
Okay, great. So first of all, I'm very honored to present this work that have been going on in Tunisia. I will present the watershed conceptual data model, the use of the IoT and the simulation of the SWAT-MODFLOW, and how we have integrated it into FIWARE. And in fact, this work have been used to be integrated in an open lab in the Morneg Plain in north of Tunisia, which is more or less 280 kilometers square. The lab, in fact, several PhD engineers and researchers are involved. This lab is composed by multi-sectorial skills, and it started in 2020, and it has founded as a strategic national initiative by the Tunisian government. So we have PhD and researcher from the National Agronomic Institute of Tunisia, from the Carthage University. I am from the National School of Science and Advanced Technology of also Carthage University. And also we have some engineers from the higher schools of communication of Tunis, Carthage University. We have also a couple of engineers working for the lab, and a couple of students and trainees in diverse skills in instrumentation, embedded systems, IoT, and so on. First of all, what is a watershed? The watershed is our working area. Is the area where the water is collected when it comes from the rain, when it comes from the snow, when it comes for other neighbor watershed, and it's been collected in a dam or a lake, or it's going to the groundwater in the aquifer, and then in a zone or in an area, it's a collection of multiple of watersheds. That means between a watershed and a watershed, we can find a watershed. So there is a boundary between watershed, and it means the boundary is where is going the water is going on the right side or on the left side. And this is defined the boundary, and this is defined the limitation. And this is one of the goal of the simulation, to define the geology aspects of the area. So one of the highest challenge in water worldwide, and mainly in our concern in Africa and in our Mediterranean countries, is the importance of the use of the water, the optimization of the use of the water. When the water is missing, and just we have too few quantity of water, what to do with it? 30% of the land are arid or semi-arid in the world land in worldwide, and 44% of the cultivated land are in arid and semi-arid land. And that's why it's very important to try to estimate the quantity of the water in zone by zone, watershed by watershed. So we define these three objectives in our work. So the watershed water quantity estimation. How can we estimate quantity of the water in the groundwater, on the lake, and the rivers, and so on? And once we estimated that water, what to do with it? how can we make a good decision on the right use of the water, how to bring the right data, the right information to the decision-making persons. And finally, how can we make right prediction on the incoming or in the quantity of water presence. So first of all, we are using these two simulation models. The first one is SWAT, which is a soil and water assessment tool in a watershed to river model, which is the simulation model to estimate quantity in a surface area. It's in fact widely also used in the assessing the soil erosion and prevention and control of the erosion. The second one is MODFLOW, which is a modular hydrologic model considered as an international standard for simulating and predicting groundwater conditions and groundwater to surface and surface to groundwater interactions. And a lot of work have been done in order to develop an open source and a free software, which is a combination of the two, to have these tools, software tools, to be used to estimate the quantity of water in a watershed. Plus this, we have different kinds of sensors that we are using. We have more or less 5 types of sensors: rainfall, and we have specific that we already have been developed in our lab, used for high condition of weather change. That means when we have a lot of quantity of water in a small times. So the sensors have to give right data for the in order to evaluate the quantity of water in short of time. So we have also sensors for the levels of the rivers, for the dam, for the lake. We also taking the air temperature and humidity. That means all the condition in the air, condition for the soil temperature and the moisture, and then the condition on the groundwater. So the level of the groundwater with in making measure of the pressure on the water in the groundwater, and also some temperature. But also we are taking some quality measurements in order to see what is the is there any injection of salt water from the sea or other sources. We are all integrating the IoT data, all the integrating the open source software into FIWARE in order to have a coherent system and exchanging data between the systems. So we're using all this data plus some external data like open data, external weather data, in order to cross the data and have let's say better precision on the simulation. So we can, from the FIWARE platform, we have a real-time display. We can build the scenarios and reporting on the simulation, and we also build the prediction scenarios, and we build the reporting from all this data. So we also made work with all the FIWARE team in order to use the qualification of the data and using the smart data models, and we are participating and contributing in the smart data models for the watershed aspects. And we also, thanks to FIWARE, because it was easy to integrate the machine learning algorithm in order to make all the prediction scenarios to estimate the quantity of the waters. So we have different process. We have batch process that we can send. We also have continuous analyze and learning on the data in order to anchor the simulation and with the IoT data. So from the IoT data, we are having more precision on the parameters of the simulation on the SWAT-MODFLOW parameters, but we are also building, as I will show you, we are also building more better construction on the information. So what is the water when we estimate all this water in the watershed? What is it for? It's mainly in the important needs are for the big cultures like cereals, and it's also for the animals. It's for all the arborifers like olive oils and other type of trees.
1 minute, Harry.
Okay, and it's also used for the drinkable water. And what would be the decision to use? Is there, if we give to all the needs, so it will, we probably make some, let's say, problems. So we are here helping authorities in these dry conditions to have the right decision. And in fact, there is always big fight between different water users to let's say who will have the use in primary. So in fact, the main problem we are facing that we have very little data collected. So we are collecting data from the 70s, and it's not enough in order to have some algorithm of prediction. So with the simulation, we are enhancing the data, we are interpolating the data, and from here, when we are enhancing all the data, we can then make scenarios, we can make prediction from here, and then you can see that we have here the orange, this is one scenario, the green one is another scenario, and the yellow is another scenario. For example, if we give all the water to all the scenario, to all the needs, so we have a scenario. If we have, let's say, bad weather condition, it's also another scenario. And this is it, Fernando. I finished, and thank you very much.
I appreciate your presentation. This is very amazing to see how can we apply the FIWARE technology in the water sector outside of Europe, not only talking about the European countries, but this is the first presentation outside of a European country. So thank you very much for joining. Okay, then move to the wrap-up session. This is I prepared some analysis of the different presentations that I see today, in which I identify different strengths, weaknesses, opportunities, and threats. No? Regarding the strengths, I identified that the European Commission is putting a lot of effort in order to develop a strategic line regarding the water and digitalization of the water sector through different programs, ICT for Sustainable Growth, European Partnership Water Security for the Planet, Water for All, and also the European Green Deal Initiative that was presented at the beginning of the session by Panagiotis. Also, we saw that we have a lot of research and innovation ecosystem collaboration organized around the digital water. We have the example of the ICT for Water and also the Digital Water 2020, in which not only the current working projects in the cluster is working together, but also we see external projects related to the water sector that is coming to this synergy group. And also we see the support from Horizon Europe to promote activities to demonstrate the digital solution and help creating a smart water value chain. This is also presented by Panagiotis at the beginning of the session. The weakness that I identified, that almost all of you know very well, is the complex and fragmented landscape regarding the water sector, and also this sector is very low digitalized. This is a weakness, but of course this is also an opportunity for the sector. No? Also, there is let's say, an unsatisfying implementation of the EU water-related policies, at least at the level of European countries, but also could be applied to the other countries outside of Europe, because this is a very complex scenario, very complex landscape, and it's very, let's say, frustrating sometimes. Lack of standard at the EU level, that this is also a good opportunity in terms of FIWARE. So regarding the opportunities, I identify that the use of the open source clearly improve the opportunities to relaunch this water sector. The definition and use of smart data models clearly improve the interoperability between the solutions and also the interoperability of the data. A standard on water management could be a good opportunity also to be improved. Of course, taking into account the smart data models initiative and also the ETSI LD, but also taking into account any other standards initiative in Europe like XSRF, or XSRF for water. And also, this is linked to the presentation of Panagiotis, is the opportunity that is offered the smart water to support the smart agri-food, smart industry, smart cities, and smart energy, because all of those sectors, in my opinion, are very close connected. Threats. Well, the threats is we need an appropriate legal and institutional frameworks in order to guarantee that the water resources are managed and used in a sustainable way, not only in Europe. This is something that is we need to think at the world level. Of course, we need to increase the digitalization of water, sanitization, access and sanitation, hygienization, and so on of the services. Is investment and financial support for water development at the regional level, national, European level. This is, of course, is something that is repeat everywhere, every time. Last but not least, imagine all the allocating water across competing developmental sectors to meet multiple challenges. Also could be related to the opportunities of multiple alignment with different sectors. Regarding the digital water, I have identified that the developing of intelligent management of water flow using bidirectional communication is a hot topic that need to be read. The deploying of real-time smart monitoring and decision-making is something that we see in different cases. Another topic is boosting digitalization of the rural water sector. This is also briefly mentioned by Panagiotis at the beginning of the session. That is something that is interesting to cover. We need to work in the advancing autonomous and intelligent sensor capabilities. We see something regarding the presentation from Nicolás Caradot about the different sensors in rivers and so on. We need to talk about the deployment of flexible and scalable data management and data analysis services, data spaces. This is something that is also covered by the FIWARE. And also the advancing research for low-cost and reliable sensors and transducer. This is something that, of course, we need to work on that just to reduce the cost and increase the availability of those sensors. And last but not least, creating digital usable representation of a water system through the digital twins, taking into account also the activity of the FIWARE for water regarding the integration of those simulation tools. What FIWARE offers is advancing data sharing and interoperability through the smart data models initiative and the existing NGS-ILD, the modeling of digital twin water data and architecture using FIWARE enabling technology and enabling the free flow of non-personal data regarding, of course, the data, water data. FIWARE can offer as well the developing of a common information exchange standards following a cross-domain approach, like we see during all the day today, and the integration of standards water management systems, like we see in the case of Greek today, and in the different solution that also the solution that was implemented by Tunisia regarding the watershed. Also, we see that the integration of a simulation tool like EPANET, MODFLOW, and SWAP is easy to go ahead in the FIWARE architecture, and last but not least, the community of adopters. And now I wanted to give the floor to our CEO, Ulrich Salem, to talk about the initiative of the Smart Water Mission Support Committee.
Yeah, Fernando, thank you very much. And also thank you to all the different speakers in this really great lineup, underlining the importance of water and the digitization, the role digitization can play in managing water, in predicting water situations. And that was the reason why the board of directors of the FIWARE Foundation decided to nominate the smart water domain as the 5th domain, which will in the future be supported by the FIWARE ecosystem. And for the other 4 domains, we have already a mission support committee in place. And I would like to ask you, those who are active players in this area, to volunteer to build this group of mission support committee. And if you're interested, please contact Fernando, who is managing these activities. And then let's bring together a mission support committee. The first step will be to create a charter. We have a template for that and examples from other mission support committees. And then start the work, bringing FIWARE technology in the smart water sector. So thank you very much. We are over time, I think.
Yes.
Therefore, handing back, Fernando, to you for the closing.
Yes, it's just a matter to, I put here the initial objectives of this mission support committee, in which you see the main purpose of the activity that we wanted to reiterate here. Of course, you can send me an email and we can provide you access to the mission support committee. The next action points is just to define the different action there and so on and so forth. So nothing special, just because we need to close. I wanted to have the opportunity to talk about the challenge that we mentioned at the beginning of the session, just to keep this is something that is up and running. Yes, we have finished here with I put a very nice quote that I took from the United Nations World Water Development Report. Keep in mind that decisions that determine how water resources are used or abused are not made by the water managers alone, but driven by various socio-economic development objectives and the operational decision to achieve them. So I finish here. Thank you very much for joining. Sorry if I spent more time than expected, but I am very happy to see you in the mission support committee. have here my email and also the mailing list of this Smart Water Mission Support Committee. Thank you very much, and talk to you soon.